Hi guys, welcome to a new video on differentiation paper 2 under math studies. This video deals with questions that are of a level 2 difficulty, so basic but slightly more advanced than level 1. I shall solve the 3 questions on the screen in front of you, and I shall begin with question 1 shortly. I shall now solve paper 2 November 2000 question 8I. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So in question A, you are required to differentiate f of x with respect to x, given that f of x is x to the power of 3 minus 3x squared plus 3x. So let's take a look. There is your derivative function. 3x squared minus 6x plus 3. Next, you are required to copy and complete the table below. So when x equals -1, if I want to find f of x, I simply plug -1 into this function, and this shall give me -7. When x equals 0, if I want to find f dash of x, I simply need to plug 0 into the purple equation, and this shall give me the value of f dash of x. Similarly, when x equals 2 and I need to find f dash of x, I shall simply plug 2 into the purple equation, and this shall again give me a value of 3. So question C requires that you use the information in your table to sketch the graph of f of x. Let's take a look. That is how the sketch should look like. And of course, in current exam questions, this is not really relevant because you have your GDC and you can sketch on your GDC and then just copy the answer onto the graph paper. Question D is out of scope of this syllabus because you are not required to know where inflection points are. Question E says write down the gradient of the tangent to the curve at the point 3, 9. This is a very important question. So what is the gradient of the tangent at the point 3, 9? Simply it is the value of f dash of x when x equals 3. Because the x value here is 3. So I need to find f dash of x when x is 3. So when x is 3, f dash of x is 12. Hence the gradient is 12. There is your answer. So this concludes the question. Kindly take a minute to write this down if you will. I hope you have found this question easy to understand. I shall attempt to solve paper 2 May 2005 question 8I. Kindly take a minute, pause the video, try to solve, and the answer shall follow through shortly. So in question A, you are required to evaluate f of 1, and then in B you are required to evaluate f dash of x, and in C you are required to evaluate f dash of 2. So let's take a look at how to do so. So there is the original function in black right there. In order to find f of 1, all I have to do is plug 1 instead of x into the original function and evaluate. So I'll have 1 here instead of this x cubed, 1 here and 1 here. This is what I've done right there, and the answer is 3. Next, I'm required to find f dash of x, which is the derivative of this function. So 2x cubed gives me 6x squared. I multiplied the 3 by the 2 to get the 6, and the power is reduced by 1, so the 3 becomes a 2. Next, I want to differentiate negative 5x squared, so again I multiply the power, which is 2, by the coefficient, which is 5. So this gives me 10, and of course the negative sign remains as it is. And the power is reduced by 1, so instead of x power 2 I get just x. Next, I want to differentiate 7x, which of course gives me 7. And finally, the 1 is a constant, so it vanishes in the derivative function. In question C, you are required to find f dash of 2, and this is simply found by plugging 2 instead of this x. So I get 6 times 2 squared minus 10 times 2 plus 7, and this gives me a final answer of 11. In question D, I'm required to state whether the function is increasing or decreasing at x equals 2. Since I already have the value of f dash of 2, which is a function of the slope, I can simply analyze that if the slope is positive, then the function is increasing, or else if the slope is negative, then the function is decreasing. So since f dash of 2 is positive, hence the function is increasing because this is a positive number. Now, in question E, I am given a graph and I'm asked whether it is possible that this is the graph of f of x. So since I've already figured out that the function is actually increasing when x equals 2, I can tell from this graph that this is not the case, because when x equals 2, the function is obviously decreasing. Hence, this is not possibly the graph of f of x, and the reason is that in this graph the function is decreasing when x equals 2, whereas in this formula the function is increasing when x equals 2. So this concludes our question. Take a minute to copy the answers down if you will. I hope you have found this easy. I shall now attempt to solve paper 2, May 2006, question 3. Take a minute, try to solve, and the answer shall follow through shortly. So in question A, I'm required to find g of 2. So I've written down my equation on the GDC: 1 over 8 x power 4 plus 9 over 4 x squared minus 5x plus 7. I shall then click on trace. There is my graph. I want to find the value of the function when x equals 2. So I shall just click on second, trace, find value, and I shall type 2, and the calculator tells me that when x equals 2, y equals 8. Next, for question B, I'm required to calculate g dash of x. So there is your answer to A. And for B, I shall simply differentiate this function right there, getting 4 over 8 x cubed instead of this term, 18 over 4 x squared instead of this term. Excuse me, this is supposed to be 18 over 4x, not x squared, excuse me. There, we have fixed it. And negative 5x becomes negative 5. And if I want to simplify the two fractions, there is a way to do that. 4 over 8 becomes 1 over 2, and 18 over 4 becomes 9 over 2. So the blue expression is the final answer for B. So in question C, we are asked to show that the gradient of T1 is 8, where T1 is a tangent to g of x at the point where x equals 2. So let's take a look. I need to find the slope or the gradient when x equals 2. So I shall press on second, trace dy by dx 2, and the calculator tells me that the gradient is 8. Hence, g dash of x when x equals 2, or simply g dash of 2 is 8. This is the slope of the tangent when x equals 2. Next, in question C double I, I'm required to find the equation of T1, which is again the tangent whose gradient is 8. I need to write the equation in the form of y equals mx plus c. So in order to find the equation of a tangent, we need two things. We need the slope of the tangent or the gradient of the tangent, and we already have this. We know that the gradient is 8, and we need a point that lies on this tangent. And usually this is the point where the tangent intersects the curve, and we know from the question that this is the point where x equals 2. But as you know, a point has to have an x coordinate and a y coordinate. So how do we get the y coordinate? Simply by plugging the 2 into the original function to get g of 2, or the value of y when x equals 2. And luckily this value has already been obtained in question A, so we already have the y value when x equals 2. So again we need the slope, which is 8, and the point, which is x and y. So we have everything we need. Next we just need to use the point slope formula. So there is our slope, there is our x value, and there is our y value, which we have obtained from question A. I shall plug these into the point slope formula. I shall expand and simplify, and the final equation of the tangent is y equals 8x minus 8. In question D, I am told that the graph has another tangent at the point 1,35 over 8, and that this tangent has 0 gradient. So I want to write down the equation of T2. Again, I need a point and a slope, and they are provided in the question. There is my point and there is my slope. So all I have to do is substitute these values into the point slope formula. So y minus y1 equals m times x minus x1, and the equation is y equals 35 over 8. Next, in question E, I'm required to sketch the graph of y equals g of x in the region 0 less than x less than 3 and 0 less than y less than 22. So I shall adjust the window on my calculator accordingly. I have modified the coordinates on my window, and I shall then click on trace. And there is the graph that I need to draw. And in double I, I'm required to add the two tangents which we have previously obtained to my drawing. So let's take a look at what the final drawing should look like. There is the curve as per the marking scheme, and thankfully it looks a lot like the one on the GDC. And we have added the two tangents at the point where x equals 2 and at the point where x equals 1. So I just need to draw a tangent to the curve at the point where x equals 2 and at the point where x equals 1. So the marking scheme tells me that the tangents must be drawn at the correct points, and they must be tangents and straight lines. And by tangents they mean that they must touch the curve at exactly one point. You cannot draw a line here, for example, that intersects the curve twice. It has to touch the curve barely at point where x equals 2. Also note that there are some conditions for the sketch of the curve. The window must clearly have used the x values from 0 to 3 and the y values from 0 to 22. These are the values that we have adjusted our window to on the GDC. Axis labels are not required. Some indication of scale must be present, so you need to show that you understand where roughly the y values are and where the x values are. So tick marks or single numbers on axes are enough for you to get the mark for that. And you need the correct shape, of course, as per the GDC, and you need the minimum to be in approximately the correct position. So this concludes our question. Take another look at the answer. I hope you have found this useful.